friends, today we will solve few problems that is asked in SSC JE electrical in the year of 2016. Okay friends, now let me solve the first question. The RMS value of sine wave is 100 amps. Its peak value is dash. Okay, this is the question that is asked in the year of 2016 in SSC JE. Okay, see the question is the RMS value of sine wave is 100 amps. Its peak value is dash. Okay, we will solve this. We will solve. See the RMS value is 100 amps. Here we need to find the value of peak value when the sine wave is 100 amps. Okay, this is the question. Since it is a direct question, because we having the formula for the peak value, that is peak value is equal to 1.41 into RMS. This is the formula for identifying the peak value. Peak value is also called the maximum value. Both are the same. Okay, this is the formula 1.41 into RMS. 1.41 is nothing but the crest factor of AC. Crest factor. That is 1.41. Since we got the formula, just we need to substitute the values in the formula. Okay, that is 1.41 into 100. So if we multiply this both, finally we got 141 as the answer. This 1.41 answer. So from the given option, the closest value to the 141 is 141.4. Okay, option 2 is the answer for this question. That is, the peak value is 141.4 when the RMS value of sine wave is 100 amps. Okay, the answer is 141.4. Okay, this is the question. Sorry, this is the answer. Okay, now we will solve the second question. The two sinusoidal EMFs are given as E1 is equal to A sin omega t plus pi by 4, and the second EMF E2 is equal to B sin of omega t. Sorry, here it is omega, that is angular frequency, omega t minus pi by 6. The phase difference between the two quantities in degrees is dash. Okay, here we need to find the phase difference of two EMFs. That is, this is the first EMF and this is the second EMF. Just we need to find the phase difference. Okay, here the first phase is the sine of omega t plus pi by 4. This is the first EMF, and the second EMF is B of sine omega t of minus pi by 6. Okay, here this is the phase value of two EMF. Here we are asking, we need to find the phase difference between the two quantities. So just we need to subtract this both. Just we need to find the difference between this both phase value. So that is omega t of, that is angular frequency, pi by 4 minus omega t minus pi by 6. Just we need to find the value of this both. So the final answer will be omega t plus pi by 4 minus omega t plus of pi by 6. So when we multiply minus into minus, it will be converted into plus. So finally these two angular frequencies will get cancelled. So this 5 by 4 plus pi by 6. So if we solve this, we will get, so 6 pi plus 4 pi, that is 10 pi by 24. So 5 pi by 12, that is 2 5 are 10 and 12, so 5 pi by 12. So 5 in terms of degrees, to convert this 5 pi by 2, to convert into degree, just we need to substitute the value for the pi, that is 180 degree. So I will solve here. So equal to 5 into 180 by 4, that is 6 2s are 12, 6 3s are 18, 2 1s are 2, 2 15s are 30, so 15 into 5 is equal to 75. This is the answer. So the answer is option 1, 75 degree. This is the answer. Okay. So for the second question, we got the answer, that is 75 degree. Okay. Okay friends, now let us solve the third question. The insulation resistance of cable of length 100 km is 1 megohm. For a length of 100 km of a same cable, the insulation resistance will be dash. Okay, this is the question. Consider this is a cable of 10 km having a resistance of resistance equal to 1 megohm, which is equal to 1 into 10 to the power of 6 ohm for 1 km. So 10 km, we are having the resistance value of 1 megohm, which is nothing but 10 to the power of 6 ohm. So the same cable is elongated for 100 km. Okay, that is 10, 20, 30, 40, 50, 60, 70, 80, 90 and 100. So the same cable of 1 megohm is elongated from 10 km to 100 km. So what is the insulation resistance value of this cable? This is the question. R is equal to what? Okay, the most of us we will think just we need to multiply the 1 megohm into 10, since because the distance is increased, so the resistance will be maybe increased, like that we will thought, but the answer is not like this. We know that when the area is increased, the resistance will be decreased. Okay, this is the concept, which is nothing but, that is the resistance is inversely proportional to length. Okay, this is the concept. So by applying this concept, we can find that R1 by R2 is equal to R2 is equal to L2 by L1. Okay, if we substitute the value, just we need to find the value of R2. So R2 is equal to R1 into L1 by L2. So first resistance values. Here the R1 is, the initial resistance is 1 megohm, so L1 is equal to 10 and L2 is equal to 100. So if we substitute this value, we will get 10 to the power of 6 into length 10 by 100. So finally you will get 10 to the power of 7 by 10 to the power of 2. So if you solve this, you will get 10 to the power of 5, which is nothing but 0.1 megohm. Okay, this is the answer. So the answer is option 3, 0.1 megohm. Okay. Okay friends, now we will solve the third question. A 100 watt light bulb burns on an average of 100 hours a day for 1 week. A weekly consumption of energy will be dash. Okay, this is the question. Consider this is the lamp. It is glowing for 100 hours per day. So for 1 hour, it consumes 100 watts. So for 1 day, it consumes this for 1 hour. So for 1 day, it will lose for 10 hours. So for 1 day, it will consume 100 into 10. That is 1 unit. It is nothing but 1 kilowatt hour or 1000 watts. Okay, for 1 day it will consume 1000 watts. So for the weekly consumption, the energy will be dash. Okay, so for a week we are having 7 days. Just we need to multiply directly. So 7 into 1000. That is, the answer is 7 unit. Okay, this is the answer. So the option is first one, 7 unit. Okay, this is the answer. Okay friends, now let us solve the final problem. A magnetic circuit requires 800 ampere turn to produce a certain quantity of flux in a magnetic circuit. If its excitation coil has 100 turns and 5 ohm resistance, the voltage applied in the exciting coil is dash. Okay, I am once again reading the question. A magnetic circuit requires 800 ampere turns to produce a certain quantity of flux in a magnetic circuit. If its excitation coil has 100 turns and 5 ohm resistance, the voltage to be applied in the exciting coil is dash. Okay, this is the question. So from the given, we came to know that the ampere turns is 800 and the resistance is 5 ohm and the number of turns is 100 turns. So from the given, finally we need to find the value of voltage. So in terms of magnetic circuit, the formula is E is equal to IR. So we having the value for R, that is 5 ohm. Just we need to find the value of I, that is value of current. So from the given, we came to know that the value of Ni is equal to 800, which is nothing but, so this is the formula, that is Ni is equal to 800 ampere turns. So I is equal to 800 by N. So 800 by N is nothing but the number of turns, that is 100, which is 8 amps. I is 8 amps. So if we apply the formula here, is equal to IR, I is 8 into R is 5 ohm. So if you multiply this, we will got 40 volt. So the 40 volt is the answer. So the answer is option 2. So I will just explain once again. A magnetic circuit requires 800 ampere turns to produce a certain quantity of magnetic flux. So ampere is nothing but the Ni. That is, ampere is nothing but current I, and the turns will be number of turns, which in this is nothing but A denotes for the current and T denotes for turns, which is nothing but the N. That's why I am writing here Ni is equal to 800. So Ni is equal to 800, and if its excitation coil has 100 turns, which is N is equal to 100 turns, and the resistance is 5 ohm, so R is equal to 5 ohm, the voltage applied in the excitation coil is dash. Okay, we know the formula of voltage is E is equal to IR. Here we know the value of R is 5 ohm, so we need to find the value of I, current. So from the given question, we came to know that Ni is equal to 800. So for I is equal to 800 by N, we know the value of N, which is nothing but the 100 turns. So if we substitute the values, here we came to know that the value of current is 8 amps. So finally we got the value of current. Just we need to substitute the values in the actual formula, that is E is equal to IR. So I is 8 and R is 5. So if you multiply the both, we got the answer as 40 volt. Okay. So the option 2 is the correct answer. Okay friends, that's all about today's video. In the next video, we will solve few problems that is asked in SSC JE. Okay, do support and thanks for watching. Thank you.